Welcome to Space for Sleep, your peaceful corner in the cosmos. Here we explore the universe with gentle narration, soothing voices, and calming science stories. Whether you're looking to relax, study, or drift into restful sleep, our channel invites you on a tranquil journey through space and time. Subscribe and join us as we uncover the mysteries of the cosmos, softly and slowly. Introduction: A journey to the end. What happens when everything ends? It's a question that lingers not only in the minds of philosophers and poets, but also in the minds of physicists, those who gaze at the cosmos and dare to imagine its ultimate fate. In this audiobook, we walk hand in hand with one of the most compelling scientific communicators of our time, Dr. Katie Mack. With clarity, humor, and humility, she invites us to explore the farthest reaches of time and space, to understand how everything, stars, galaxies, atoms, and even the fabric of space-time might one day come to a close. Dr. Catherine Mack, known to many as Katie Mack, is a theoretical astrophysicist and cosmologist whose work is not only grounded in the highest levels of scientific inquiry, but also remarkably accessible. Her ability to make the cosmos feel personal has captivated audiences around the world. Through lectures, books, and countless interviews, she brings the language of the universe to the human scale. Her mission is simple yet profound: to explain, without losing the poetry, the terrifying and beautiful truth about our place in the cosmos, and what might happen when it all fades away. But why speak of endings? Because endings, in their own strange way, help us understand beginnings. They help us grasp the nature of time, the forces that govern our universe, and the fragile balance that allows life, conscious life, to emerge and reflect on its own existence. By understanding how everything might end, we gain clarity about why things are the way they are now. We start to see the universe not just as a collection of stars and galaxies, but as a living story, one with a potential final chapter written in the laws of physics themselves. In this journey, we will explore 5 of the most scientifically grounded scenarios for the end of the universe. Some are slow and silent, like the heat death, where time fades into an eternal cold. Others are violent and abrupt, like the Big Rip, where space itself tears apart every structure in existence. Still others are deeply unsettling, such as vacuum decay, a quantum ticking time bomb that could erase everything in an instant, without warning. And yet, this is not a story of despair. Katie Mack reminds us that thinking about the end is not about mourning, it's about understanding. It's about marveling at the beauty of a cosmos that evolves, transforms, and eventually ceases, just like everything else. It's about confronting our insignificance and, paradoxically, finding meaning in that. If the universe must end, then our moment, this fleeting instant of awareness, becomes all the more precious. Each chapter in this audiobook will take you deeper into one of these endgame scenarios. We'll talk about physics, of course, but we'll also talk about awe, about fear, about the strange comfort that comes from accepting that we're part of a much grander tale, one that may not have a happy ending, but has meaning nonetheless. So get comfortable. Let your thoughts drift through time and space. The story we're about to tell is both scientific and existential. It's built from equations, theories, and observations, but also from wonder, from mystery, from the eternal human desire to know how the story ends. This is the story of the end of everything. And strangely enough, it begins now. Chapter 1. Welcome to the End. Katie Mack's Cosmic Vision. The night sky has always whispered questions to us, soft, ancient riddles carried on the light of distant stars. For centuries, we've stared upward, wondering how it all began. But fewer of us have asked the equally profound question, how will it all end? For Dr. Katie Mack, this question is more than an academic curiosity. It's a doorway into some of the most beautiful, terrifying, and intellectually thrilling ideas that modern science has to offer. Her approach is unlike that of many theoretical physicists. While her work is grounded in mathematical rigor and cosmological theory, her voice is human, full of wonder, dry wit, and almost poetic obsession with the fate of everything. From her early days as a curious child staring into the void to her career as a leading voice in theoretical astrophysics, Katie Mack has carried within her a sense of cosmic perspective. She is not merely trying to predict the doom of the universe. She is helping us feel something deeper about the story we're living in. Her book, The End of Everything, Astrophysically Speaking, is a cosmic elegy, a gentle yet rigorous exploration of the ways our universe might come to a close. In it, she doesn't just outline the science, she invites us into it, translating equations into emotions and theories into stories. What makes her vision unique is the tone she sets. She doesn't speak as an oracle from a tower of equations. She speaks as a fellow traveler, someone who shares our confusion, our curiosity, and even our existential dread. She talks about attending scientific conferences where doom is discussed with casual indifference over coffee. She jokes about the irony of cosmic destruction being oddly beautiful. And she reminds us again and again that contemplating the end doesn't have to be paralyzing. In fact, it can be strangely liberating. In Mack's hands, the death of the universe becomes less of a horror story and more of an epic. And like all epics, it deserves to be told in full, with all the strange physics, terrifying concepts, and cosmic plot twists intact. The framework she offers us begins with a critical concept. The universe is not static. It is a dynamic, evolving thing. It expands, it cools, structures form, collapse, reform. Nothing is forever. Not stars, not galaxies, not even the laws that govern everything. This evolution is central to all of the end-of-universe theories. Without change, there can be no ending. But because there is change, there must eventually be a final chapter. Katie walks us through 5 major theoretical endings, each grounded in real physics, each carrying its own tone and tempo. The heat death, or the big freeze, is slow and quiet, a gentle fading into cold stillness. The Big Rip is violent and terrifying, space itself accelerating until it shreds everything. The vacuum decay is a quantum horror, invisible and unstoppable. The Big Crunch is a reversal of cosmic expansion, ending in fire. And the Bounce, a more speculative possibility, imagines a universe that collapses, only to be born again. These are not fantasies, they're scientific possibilities, rooted in our current understanding of general relativity, quantum mechanics, dark energy, and particle physics. And yet each one carries with it something more than mere equations. Each one offers us a story about impermanence, about entropy, about the limits of what we can know, and the beauty of trying anyway. Katie Mack doesn't shy away from the philosophical implications. She understands that we're not just asking how will it end, we're asking why we exist at all and what it means to be aware of our own impermanence. She brings us back again and again to this idea. The universe doesn't owe us comfort, but in facing its truths, even the hardest ones, we can find a different kind of peace. For those unfamiliar with cosmology, her explanations are a revelation. She makes dark energy, quantum tunneling, and entropy feel like part of a narrative rather than alien concepts. She uses metaphors that stay with you long after the science has settled, like the idea of the universe as a cup of coffee slowly going cold, or a field of snow that could, at any moment, collapse into something entirely different. In this chapter of our audiobook, we begin not just with facts, but with a tone. Katie Mack's tone. Humble, playful, brilliant. She reminds us that being afraid of the end doesn't make you weak. It makes you human. And being curious about the end, that might just be the most human thing of all. So, before we plunge into the deep end of physics, the dark energy, the Higgs field, the curvature of space-time, we pause here with Katie at the edge of understanding. She opens the door not with answers, but with questions. Not with fear, but with wonder. As the rest of this audiobook unfolds, we will explore each doomsday scenario in detail. But let this be our compass. The universe is a place of change, of birth and death, of astonishing scale and quiet inevitability. In this grand story, we are temporary narrators, and the cosmos, in all its cold elegance, is listening. Let us begin.
The stars above us seem eternal, scattered like diamonds across the velvet sky. We look up and imagine endlessness, a cosmos stretching forever into the deep black, timeless and vast. But what if everything we see, and everything we are, is headed toward an unavoidable end? What if the universe, majestic and ancient, is living on borrowed time? This question lies at the heart of Katie Mack's fascination with cosmology. In a voice that blends curiosity with clarity, she brings us face to face with one of the most dramatic questions in science. How does the universe end? From distant quasars to the delicate shimmer of cosmic background radiation, the clues are already written into the cosmos. We just have to know how to read them. To understand how something ends, we must first understand how it began. The story of our universe started with the Big Bang, an event so dense and hot that space and time themselves were born within it. From a fraction of a second after that primordial flash, the cosmos began expanding, and it has never stopped. Galaxies raced apart, stars formed from clouds of hydrogen, and planets emerged around them. Somewhere on one of those planets, life began to ask questions. But while life emerged in pockets, the universe kept growing colder and more diffuse. The expansion was not slowing down, as scientists once thought. It was accelerating. This discovery, made in the late 1990s, shocked the scientific community. Something was driving the galaxies apart faster and faster. That something was given a name: dark energy, a mysterious force that now makes up roughly 70% of the entire cosmos. Dark energy, as it turns out, is a crucial player in our story. Depending on how it behaves over time, it could determine everything about the universe's future. Will the expansion slow, reverse, or continue forever? Will the cosmos rip itself apart or simply fade into stillness? These are not mere philosophical musings. They are testable scientific questions, and Katie Mack has made it her mission to explore them. In this chapter, we begin our quiet journey through the cosmos's possible fates. Katie introduces us to the first key concept. The universe is not static. The ancient idea of a perfect, unchanging universe died with the discovery of cosmic expansion. We now live with the knowledge that everything is moving away from everything else. And with that motion comes entropy, cooling, and decay. We also explore how astrophysicists simulate the future. With telescopes that look billions of years into the past, we can see galaxies as they once were. By comparing those ancient structures with more recent ones, we glimpse the patterns of evolution. With supercomputers, scientists model those patterns into the future, guided by the rules of physics we know, and sometimes by rules we only suspect. Katie Mack does something rare in this realm. She makes this unsettling journey comforting. With warmth and wit, she reminds us that understanding the universe's end is part of understanding ourselves. We are stardust, after all. The elements in our bodies were forged in the hearts of dying stars. We are a temporary gathering of particles, beautiful and conscious for a flicker of time in a universe that may one day go quiet. As you listen, let the questions settle in. What happens when the stars go out? When even the atoms fade away? Does anything remain after everything ends? In the coming chapters, we'll explore 5 major theories of cosmic destruction, each stranger and more poetic than the last. Whether the universe ends in fire, ice, silence, or shattering, one thing is certain: this story has a final page. And we're turning the first one now.
Chapter 2: The Big Crunch, Gravity's Final Act. The universe, vast and ever-expanding, is governed by forces both familiar and mysterious. Among these, gravity stands as one of the most powerful and potentially the final arbiter of cosmic destiny. Imagine for a moment a universe where the relentless outward push of expansion slows, halts, and reverses, where the stars, galaxies, and all matter begin to draw inexorably back together, collapsing into an ultimate cosmic finale. This is the vision known as the Big Crunch. For much of the 20th century, the Big Crunch was a dominant theory. It offered a symmetrical counterpoint to the Big Bang. If the universe began with a fiery explosion, perhaps it would end with a fiery implosion. The idea was elegant. Gravity, the force that pulls matter together, would eventually overcome the expansion, reversing the cosmic dance and causing everything to collapse back into a singular point. To understand the Big Crunch, we must first grasp the competing forces at play in the cosmos. Since the Big Bang, space itself has been stretching, pushing galaxies away from one another. But gravity, the invisible glue, works to pull mass together. The fate of the universe hinges on which force dominates. If there were enough matter in the universe, enough mass to produce sufficient gravitational attraction, the expansion would slow down. Over billions of years, that slowing would become a reversal, initiating a contraction phase. Galaxies would stop receding and start moving closer. Eventually, stars would collide, galaxies would merge, and the universe would shrink. As this collapse accelerates, temperatures and densities would rise. Stars would burn faster, galaxies would become chaotic, and the very fabric of space-time would begin to contort. Ultimately, all matter would be crushed into an unimaginably dense singularity, perhaps resembling the state before the Big Bang itself. But what about dark energy, the mysterious force discovered in the late 1990s, which drives accelerated expansion? Its presence complicates the picture. Dark energy seems to push the universe apart with increasing vigor, counteracting gravity's pull.
If dark energy's effects remain constant or grow stronger, the Big Crunch becomes unlikely. Still, theoretical physicists have explored variations. What if dark energy weakens or changes over time? Could gravity eventually reclaim dominance? These questions remain open, fueling research and debate. The Big Crunch, if it were to happen, raises profound philosophical and scientific questions. Would time itself reverse? Would this cosmic contraction erase the universe's memory, making the Big Bang a cyclical event rather than a unique beginning? Some models suggest that after the Big Crunch, a new Big Bang could occur, a big bounce, leading to an eternal cycle of creation and destruction. For now, the Big Crunch remains a powerful narrative, one of cosmic collapse and rebirth, echoing ancient myths of cycles and renewal. It invites us to consider that the universe is not a one-way journey, but a dance with time, energy, and matter that may continue indefinitely. In contemplating the Big Crunch, Katie Mack reminds us that science is a story still unfolding. Our understanding grows with each observation, each new discovery. While the Big Crunch may seem like a distant possibility, it enriches our grasp of cosmic balance and impermanence. As you listen to this vision of cosmic destiny, allow yourself to feel the paradox of an ending that might also be a beginning. The universe, vast and inscrutable, may yet surprise us with its secrets. Next, we will explore another dramatic possibility, the Big Rip, where the universe's expansion tears everything apart in a spectacular finale.
Chapter 3: The Big Rip, when space tears itself apart. The universe is expanding. This simple fact, confirmed by astronomers for nearly a century, has reshaped our understanding of cosmic destiny. But what if this expansion accelerates so dramatically that it eventually tears everything apart? Not just galaxies drifting away, but atoms, molecules, even the very fabric of space-time itself. This terrifying yet fascinating scenario is known as the Big Rip. Unlike the Big Crunch, where gravity wins and collapses the universe inward, the Big Rip imagines a future dominated by an ever stronger force pushing space apart at an accelerating rate. This force is tied to a mysterious component of the universe we call dark energy. Dark energy is thought to make up around 70% of the universe's total energy content. It acts as a kind of anti-gravity, causing the expansion of space to speed up rather than slow down. Observations of distant supernovae in the late 1990s revealed this surprising acceleration, a discovery that earned a Nobel Prize and changed cosmology forever. If the strength of dark energy increases over time, its effects could become catastrophic. Galaxies would be torn apart, stars would drift away from one another, and eventually the gravitational bonds holding planets in orbit would fail. Over an unimaginable timescale, the fabric of space itself would be stretched so thin and so fast that even atoms and subatomic particles could be ripped asunder. The Big Rip scenario unfolds gradually but relentlessly. Billions of years from now, galaxy clusters, the largest gravitationally bound structures, would lose coherence. Closer to home, the Milky Way would fall apart, stars drifting into the void. Planets no longer held by the sun's gravity would wander lonely through space. Finally, at the most extreme moment, the forces pulling space apart would overcome the strong and weak nuclear forces inside atoms. Protons and neutrons would decay, and matter as we know it would dissolve into a sea of elementary particles. Katie Mack paints this cosmic apocalypse with a mixture of scientific rigor and subtle compassion. While the Big Rip sounds like a scene from science fiction, it is grounded in the mathematics of Einstein's theory of general relativity and ongoing observations of the universe's expansion. Yet the exact nature of dark energy remains one of the biggest mysteries in physics. Is it a constant force, unchanging over time, or is it dynamic, evolving in ways that could lead to such a devastating end?
Current data is inconclusive, but as telescopes and experiments grow more precise, we may someday answer these questions. The Big Rip challenges our understanding of permanence and fragility. It forces us to confront a universe that may not only be expanding, but literally unraveling from within. For listeners, it is a story of both awe and humility, a reminder that the cosmos operates on scales and forces far beyond everyday experience. As we move forward in this audiobook, we will encounter other possible fates, some gentle, some violent, all profound. But the Big Rip stands out as a stark testament to the power of cosmic forces, the uncertainty of our knowledge, and the strange beauty found in imagining the universe's possible futures.
Chapter 4: Heat Death, a universe that fades into silence. The story of the cosmos is a story of energy, how it flows, transforms, and eventually dissipates. Among the possible endings Katie Mack explores, the heat death stands out as the quietest and most inevitable conclusion to the universe's grand tale. Heat death, also known as the Big Freeze, imagines a distant future where the universe has expanded so much that stars no longer form, galaxies drift apart, and all energy gradients, the differences in temperature and density that drive physical processes, vanish. It is a universe slowly approaching maximum entropy, a state of perfect disorder where no work can be done, no life can be sustained, and no light shines. This idea originates from the second law of thermodynamics, which states that in an isolated system, entropy, or disorder, tends to increase over time. Applied to the universe, this means that usable energy becomes less available as the cosmos ages. In the earliest moments after the Big Bang, the universe was a hot, dense soup of particles and radiation. Over billions of years, it cooled and structured itself into stars, planets, and eventually life. But this process relies on energy differences, heat flowing from hot to cold, gravity pulling matter together, nuclear fusion fueling stars. As the universe expands, these energy differences diminish. Stars exhaust their fuel, galaxies stop forming new stars, and the cosmos grows colder and darker. In the heat death scenario, after trillions of years, the universe becomes a vast expanse of cold, dark, and empty space. Black holes evaporate via Hawking radiation. Matter decays, and the temperature approaches absolute zero. Katie Mack describes this outcome not as a bleak end, but as a natural evolution, a slow fading of the cosmic fire. It is a quiet finale, marked by silence and stillness rather than catastrophic destruction. This poses profound questions about time, existence, and the meaning we assign to the universe's life cycle. If all processes cease, what happens to the arrow of time? Does time itself lose meaning when change stops? For those who find comfort in the rhythms of nature and cycles of renewal, the heat death offers a poetic metaphor. Just as all living things eventually return to dust, so too does the universe reach a state of rest. As we reflect on the possibility of heat death, Katie Mack's voice gently guides us to consider not only scientific facts, but also the emotional landscape that accompanies such cosmic endings. Next, we will explore the unsettling idea of vacuum decay, a sudden quantum event that could rewrite the fabric of reality in an instant.
Chapter 5: Vacuum Decay, the Quantum Whisper of Sudden Oblivion. The universe is a vast and complex place, governed not only by the grand forces of gravity and expansion, but also by the subtle, strange rules of quantum mechanics. Among the many mysteries that physicists ponder is the nature of the vacuum, the fabric of empty space itself. It might seem that empty space is truly empty, but in quantum physics, the vacuum is more like a bubbling sea of potential. It is filled with fields, energy fluctuations, and possibilities. This quantum vacuum is stable. or so we believe. But what if it isn't? Vacuum decay is a theoretical phenomenon where a more stable, true vacuum state exists beyond our current universe's vacuum. If such a lower energy vacuum state exists, it could suddenly appear somewhere in space, creating a bubble that expands at nearly the speed of light, obliterating everything in its path and rewriting the laws of physics. This terrifying possibility is often called the quantum ticking time bomb of the cosmos. Unlike the slow fades or gradual collapses of other cosmic endings, vacuum decay could happen without warning, a sudden catastrophic shift in reality itself. Katie Mack explains this phenomenon with both caution and wonder. While vacuum decay is a plausible scenario within our current understanding of particle physics, it remains hypothetical. No evidence suggests it is imminent, but its implications force us to confront the fragility of our universe on the most fundamental level. The bubble of true vacuum would alter the constants of nature, the forces that hold atoms together, and the structure of space-time. In essence, the universe we know would be destroyed, replaced by a new reality with different physical laws, a new cosmos incompatible with life as we understand it. Despite its terrifying nature, the concept of vacuum decay pushes physicists to probe the limits of knowledge and explore questions about the stability of our universe. It reveals how deeply intertwined the smallest scales of quantum mechanics are with the largest scales of cosmology. As you listen to this chapter, imagine the delicate balance of existence, held together by forces and fields so subtle they're almost invisible, yet so powerful that a slight change could end everything. Next, we will explore the hopeful and cyclical idea of the Big Bounce, a universe that may collapse only to be reborn again. Chapter 6, The Bounce, a universe that repeats forever. The story of the cosmos has long fascinated humanity, from its fiery beginning to its mysterious potential endings. But what if the end is not really an end? What if the universe is caught in an eternal cycle of birth, death, and rebirth? A cosmic heartbeat echoing through time without a final silence. This idea, known as the Big Bounce, suggests that the universe does not simply expand forever or collapse once and for all. Instead, after reaching a maximum size, it contracts again, ultimately collapsing into a dense state only to explode outward once more in a new Big Bang. This cycle could repeat endlessly, a cosmic dance of destruction and creation. The Big Bounce challenges the notion of a singular beginning and a singular end. Instead, it paints a picture of an infinite loop, where each ending is followed by a new beginning. The universe in this view is timeless, without a true origin or final destination, but rather an ongoing process of transformation. Katie Mack explores this concept with both scientific rigor and a gentle sense of wonder. While the Big Bounce is more speculative than some other end-of-universe scenarios, it arises naturally from certain theories of quantum gravity, which seek to unite general relativity and quantum mechanics into a cohesive framework. In these models, the extreme densities and energies at the supposed end of the universe trigger a rebound instead of a collapse into a singularity. Space and time themselves can stretch, contract, and then expand again. This cyclic cosmos offers a comforting perspective. It suggests that while individual stars, galaxies, and even universes may perish, the larger cosmic rhythm continues unabated. Each cycle could be slightly different, shaped by subtle changes in physics or initial conditions, but the dance goes on. Yet the Big Bounce also raises profound questions. If the universe repeats forever, what about memory and identity? Does anything from previous cycles survive? Or are we perpetually new beings in a new cosmos, unaware of what came before? This vision also inspires reflection on human existence. In a universe without final endings, the preciousness of each moment remains. Our lives are small notes in a grand, unending symphony. As you listen to this chapter, let yourself drift on this eternal rhythm, a pulse that carries the cosmos through endless night and dawn. Next, we will explore phantom energy and its mysterious role in shaping cosmic fate.
Chapter 7: Phantom Energy and the Endgame of Expansion. In the vast cosmic tapestry, energy takes many forms, visible and invisible, known and mysterious. One of the most enigmatic components that physicists study today is phantom energy, a hypothetical form of dark energy with properties even stranger and more powerful than the dark energy driving the accelerated expansion of the universe. Phantom energy, if it exists, would have a peculiar effect on the cosmos. Unlike normal matter or even typical dark energy, phantom energy's pressure would be so negative that it causes the universe's expansion to speed up uncontrollably. This runaway expansion could lead to a cataclysmic event similar to the Big Rip, but with unique twists and consequences. Katie Mack introduces us to this unsettling possibility with clarity and care. She explains that phantom energy would violate what physicists call the energy conditions, principles that generally maintain the stability of the cosmos. In a universe dominated by phantom energy, these conditions break down, leading to instability on the grandest scales. As phantom energy accelerates expansion, gravitationally bound systems, galaxies, solar systems, even atoms would be torn apart sooner than in other scenarios. This ultimate fate would be swift and destructive, ending the cosmic story in a violent unraveling of structure and matter. While phantom energy remains hypothetical, it's an active area of research. Observations continue to refine our understanding of dark energy's nature, testing whether it could evolve into or behave like phantom energy over time. This chapter invites listeners to grapple with the uncertainty of cosmic futures. The universe's fate is not set in stone. It depends on forces and particles we are only beginning to understand. Phantom energy reminds us of the dynamic, ever-changing nature of reality, a universe that could surprise us, for better or worse, at any moment. As we continue, we will explore the cosmic horizon, what lies beyond the limits of what we can observe, and how it shapes our understanding of the universe's end. Chapter 8: The Cosmic Horizon, What We'll Never See Again. The universe is vast beyond comprehension, but even its grandeur has limits. The cosmic horizon marks the boundary of what we can observe, an invisible curtain beyond which light has not yet reached us, and perhaps never will. Katie Mack invites us to consider this horizon not just as a limit to observation, but as a profound factor in the fate of the cosmos. As the universe expands, distant galaxies cross this horizon, slipping forever beyond our reach. This process is gradual and relentless. Galaxies that once shone brightly in our night sky will fade into invisibility, their light stretched and diluted by the expanding fabric of space. Over unimaginable timescales, the observable universe will shrink, leaving us isolated in an ever-darkening cosmic island. The cosmic horizon shapes our understanding of time, space, and the ultimate loneliness of existence. It challenges the notion that the universe is infinite in a practical sense, highlighting the boundaries imposed by cosmic expansion and the speed of light. Katie Mack explores how the cosmic horizon affects our knowledge and shapes the questions we ask about the universe's beginning and end. It reminds us that observation is limited and that some mysteries may forever elude us. As galaxies disappear beyond this horizon, the cosmic landscape grows quieter and emptier. The universe becomes a smaller, lonelier place, a reminder of both the vastness and fragility of all that we know.
This chapter encourages reflection on the limits of perception and the humility required to face the unknown. Next, we will delve into the mysterious and powerful role of black holes in the cosmic finale. Chapter 9, Black Holes, the Last Engines of the Universe. Black holes are among the most mysterious and powerful objects in the cosmos. Born from the collapse of massive stars or the mergers of galaxies, they represent regions where gravity has pulled matter into an infinitely dense point, known as a singularity. Their gravity is so intense that not even light can escape their grasp. As the universe ages and galaxies drift apart, black holes will become the dominant structures remaining, serving as the last bastions of matter and energy. Katie Mack describes them as the universe's final engines, slowly consuming, radiating energy, and shaping the cosmic landscape in ways that will last far beyond the lives of stars. In the far future, as star formation ceases and existing stars burn out, black holes will continue to grow by merging with one another and absorbing surrounding matter. Over unimaginable timescales, black holes will dominate the universe's matter content. Yet, black holes are not eternal. Through a process known as Hawking radiation, proposed by physicist Stephen Hawking, black holes slowly lose mass and energy, evaporating over time. For the most massive black holes, this process will take trillions upon trillions of years, far longer than the current age of the universe. Katie Mack explores this paradoxical existence, black holes as both destroyers and eventual victims, fading into nothingness after eons of cosmic solitude. This chapter invites us to reflect on the life cycle of these enigmatic giants, their birth, reign, and inevitable demise, and what their existence tells us about the nature of the universe. As black holes vanish, the universe moves ever closer to its final stages of quiet and darkness. Next, we will explore the era of black dwarfs and quiet stars, the twilight of stellar evolution. Chapter 10, the era of black dwarfs and quiet stars. As the universe ages, the brilliant stars that once lit up galaxies will fade and die, leaving behind a quieter, colder cosmos. After the last stars have exhausted their nuclear fuel, a new era will emerge, one dominated by the remnants of stellar evolution, black dwarfs, neutron stars, and white dwarfs, slowly cooling into darkness. Black dwarfs are the theoretical end state of white dwarfs, the dense cores left behind when medium-sized stars like our Sun exhaust their fuel. While white dwarfs still glow faintly with residual heat, black dwarfs have cooled to the point where they no longer emit significant light or heat, a cold, dark ember drifting through space. Katie Mack guides us through this quiet chapter of cosmic history, describing a universe growing dim and cold. The processes of star formation have ceased, galaxies have lost much of their visible structure, and the night sky is increasingly empty. This era is marked by stillness and slow decay. The once vibrant tapestry of stars gives way to a silent darkness, punctuated only by rare events such as collisions between compact remnants or the evaporation of black holes. Yet even in this fading cosmos, the fundamental laws of physics continue their eternal dance. The slow cooling of black dwarfs and the interactions of degenerate matter remind us that change, though subtle, never truly ceases. As we reflect on this era, Katie Mack invites us to consider the beauty in endings that are gentle rather than dramatic, an elegant fading rather than a sudden collapse. Next, we will explore the profound questions raised by the dissolution of physics itself as the universe reaches its ultimate limits.
Chapter 11, the breakdown of physics when the rules no longer apply. Our understanding of the universe rests on the laws of physics, fundamental principles that have guided scientists for centuries. From Newton's gravity to Einstein's relativity, from quantum mechanics to thermodynamics, these laws describe how matter and energy behave across scales vast and minute. But what happens when these laws themselves begin to falter? As the cosmos approaches its farthest reaches in time and space, physicists speculate that the familiar rules may no longer hold.
In extreme conditions, whether near singularities inside black holes or at the universe's ultimate fate, the known laws may break down, giving way to new, unknown physics. Katie Mack leads us into this frontier, exploring the limits of human knowledge. She explains how, in the earliest moments of the Big Bang, physics as we know it ceases to be predictive. Similarly, as the universe ages and expands toward extremes, new phenomena could emerge that challenge our current theories. This breakdown raises profound questions. Can we ever truly understand the cosmos in its entirety? Are there aspects of reality forever beyond our grasp? And if the laws of physics change or dissolve, what does that mean for the universe's destiny? In contemplating these mysteries, Katie Mack invites us to embrace the unknown, not as a void, but as a space for wonder and discovery. The edge of physics is not just an end, but a beginning for new questions and deeper understanding. As you listen, imagine the universe as a vast puzzle, with some pieces forever elusive and others waiting to be found. Next, we will explore the concept of multiverses, the possibility that our universe is but one of many. Chapter 12, The Multiverse. Many universes, many endings. What if our universe is not alone? What if, beyond the cosmic horizon, countless other universes exist, each with its own laws, its own beginnings, and its own ends? This is the tantalizing idea of the multiverse, a concept that challenges our understanding of reality and expands the cosmic story far beyond the boundaries of our observable cosmos. Katie Mack introduces the multiverse not as a science fiction fantasy, but as a serious topic of inquiry grounded in modern physics and cosmology. Various theories, from string theory to eternal inflation, suggest that our universe might be one bubble among many in a vast cosmic foam. In such a multiverse, each universe could have different physical constants, different forms of matter, or even different dimensions of space and time. Some might be short-lived, others stable for eons. Some might end in a big crunch, others in heat death, and still others in ways we cannot yet imagine. This perspective profoundly shifts how we think about cosmic endings. The fate of our universe may just be one chapter in an infinite anthology of cosmic stories. Katie Mack also discusses the philosophical and scientific challenges of the multiverse hypothesis. Since other universes might be forever beyond our observation, can we ever truly prove their existence? How does this idea influence our understanding of meaning, purpose, and uniqueness? As you listen, allow yourself to ponder the possibility of countless worlds, each with its own destiny, and the humbling thought that our universe's end might simply be a beginning elsewhere. Next, we will explore the role of cosmic inflation in shaping not only the beginning, but also the possible futures of the cosmos. Chapter 13, Cosmic Inflation, the universe's explosive growth and its implications. In the earliest moments after the Big Bang, the universe underwent an extraordinary phase known as cosmic inflation, a brief period of unimaginably rapid expansion. This stretched space itself, smoothing out irregularities and setting the stage for the cosmos we observe today. Katie Mack delves into this explosion with clarity and wonder. Inflation explains many mysteries: why the universe is so uniform on large scales, how quantum fluctuations seeded galaxies, and why the cosmic microwave background radiation is so remarkably even. But inflation also raises profound questions about the future. Some theories suggest that inflation might not have ended everywhere simultaneously. Instead, it could continue in some regions, spawning pocket universes and fueling eternal inflation, an endless creation of new universes within a grand multiverse. This eternal inflation connects deeply to ideas of cosmic endings. If inflation continues somewhere else, does that mean the universe never truly ends? Does it endlessly spawn new beginnings even as parts of it decay? Katie Mack invites us to consider inflation as both a beginning and a bridge to possible futures. It reminds us that the cosmos is dynamic and layered, full of surprises and complexities beyond everyday experience. As we listen, we are drawn into the delicate balance between chaos and order, expansion and contraction, beginnings and endings. Next, we will examine dark matter, its mysterious presence, and its influence on the universe's fate.
Chapter 14: Dark Matter, the Invisible Sculptor of the Cosmos. When we look up at the night sky, the twinkling stars and glowing galaxies captivate us with their beauty. Yet what we see, all the stars, planets, and gas, accounts for only a small fraction of what the universe truly contains. Hidden from sight, invisible to all telescopes, lies one of the greatest mysteries in cosmology: dark matter. Dark matter is a form of matter that does not emit, absorb, or reflect light. We cannot see it directly, but its presence is felt throughout the cosmos through its powerful gravitational influence. Without dark matter, the universe as we know it would not exist. It acts as the cosmic scaffold, an invisible framework upon which galaxies and clusters are built and held together. Scientists estimate that dark matter makes up about 27% of the universe's total mass energy content, far outweighing the ordinary matter that makes up stars, planets, and humans. The rest, around 68%, is attributed to dark energy, the mysterious force driving the accelerated expansion of the universe. The story of dark matter began in the 1930s, when astronomers like Fritz Zwicky observed that galaxies and clusters moved as if there were much more mass present than what was visible. Later observations of galaxy rotation curves confirmed that stars at the edges of galaxies orbit faster than expected, implying the presence of unseen mass exerting gravitational pull. But what is dark matter made of? This question has puzzled scientists for decades. Many theories suggest it could be composed of yet undiscovered particles that interact very weakly with normal matter. Candidates include WIMPs, weakly interacting massive particles, axions, and sterile neutrinos. Despite extensive searches in particle accelerators and underground detectors, no direct evidence has yet been found. Dark matter is not just a curious phenomenon, it shapes the fate of the cosmos. Its gravity competes with dark energy's repulsion, influencing how galaxies cluster, how structures grow, and ultimately how the universe expands or contracts over time. In a universe dominated by dark energy, expansion accelerates, driving galaxies apart and leading toward a cold, lonely fate. But dark matter's gravity works in opposition, pulling matter together, slowing expansion locally, and creating the rich cosmic web we observe. Katie Mack explains that understanding dark matter is key to unlocking the universe's future. If dark matter behaves differently than expected or interacts in new ways, it could alter cosmic evolution. Some theories even speculate that dark matter might decay or transform, further complicating the cosmic balance. As we reflect on dark matter, we confront the humbling reality that most of the universe is unknown to us. This invisible substance shapes everything we see, yet remains hidden, inviting us to keep exploring and questioning. Imagine the vast cosmic web, an immense, intricate structure woven by dark matter's gravity. Galaxies cluster along its filaments, forming nodes and voids, painting a three-dimensional tapestry across billions of light years.
This hidden architecture underscores the delicate interplay of forces that govern cosmic destiny. Dark matter and dark energy, two mysterious components, shape the ultimate fate of all existence. As you listen, allow yourself to marvel at the unseen, the silent sculptor of the cosmos that invites endless discovery. Next, we will journey into the nature of cosmic time and how the universe's lifespan challenges our deepest understanding of time itself. Chapter 15: Cosmic Time: The Universe's Lifespan and the Nature of Time as Woven into the Fabric of Space-Time by Einstein's Theory of Relativity. Time is a concept so fundamental to our experience that it often seems absolute and unchanging. We mark it by clocks, calendars, and cycles, day and night, seasons, lifetimes. Yet when we step beyond the familiar world into the vast cosmos, our understanding of time becomes more complex, subtle, and even mysterious. Katie Mack invites us to contemplate cosmic time, the universe's lifespan, and the very nature of time as woven into the fabric of space-time by Einstein's theory of relativity. Unlike the ticking clock in our daily lives, cosmic time is influenced by gravity, expansion, and the fundamental structure of the universe. From the fiery birth of the Big Bang to the possible ends we have explored, time stretches and bends. The universe's expansion affects how time flows in different regions of space. Near massive objects like black holes, time slows relative to distant observers, a phenomenon known as gravitational time dilation. Farther away in the emptier expanses of the cosmos, time flows more uniformly. Moreover, the universe's lifespan is staggering beyond human comprehension. Measured in billions and trillions of years, cosmic time challenges our intuition. For example, the current age of the universe is approximately 13.8 billion years, but it may continue expanding for trillions more, or possibly cycle endlessly through phases of collapse and rebirth. Katie Mack also explores the arrow of time, the direction in which time seems to flow from past to future, and its connection to entropy, the measure of disorder. According to the second law of thermodynamics, entropy increases over time, giving a directionality to time's passage. This arrow shapes everything from the formation of stars to the eventual heat death of the universe. Yet some theories speculate on the possibility of time behaving differently at the universe's beginning or end. Could time reverse, loop, or even cease to exist in extreme conditions? These questions lie at the intersection of physics, philosophy, and metaphysics. As we listen, we are reminded of time's profound role, not only in cosmic evolution, but in our own existence. Each moment is part of this grand temporal tapestry, connecting us to the universe's vast story. This chapter invites gentle reflection on time's mystery, its flow, and its meaning within the endless dance of creation and destruction. Next, we will dive into the concept of entropy and disorder, exploring how they govern the universe's fate.
Chapter 16: Entropy and Disorder: The Cosmic Rulebook. From the smallest ice cube melting in a glass to the grandest processes shaping galaxies, entropy is the invisible force guiding change and decay in the universe. But what exactly is entropy, and why does it play such a pivotal role in the cosmic story? Katie Mack leads us into this fundamental concept, rooted in thermodynamics, the branch of physics that deals with heat, energy, and work. Entropy is often described as a measure of disorder or randomness, but it is more accurately a measure of the number of ways a system can be arranged. The higher the entropy, the greater the disorder and the fewer possibilities for organized, useful energy. The second law of thermodynamics tells us that in an isolated system, like our universe, entropy tends to increase over time.
This means the universe moves from states of order to disorder, from usable energy to dispersed energy, from structure to chaos. This cosmic tendency shapes everything. Stars burn their fuel, galaxies collide and merge, and eventually, the universe approaches a state of maximum entropy, heat death, where no more work can be done and all processes grind to a halt. Katie Mack explains how entropy creates the arrow of time, giving time its direction from past to future. Without increasing entropy, time would lose its meaning and the universe would be frozen in a timeless equilibrium. Yet entropy is not just a force of destruction. It also enables complexity and life to emerge temporarily. Local decreases in entropy, such as the formation of stars, planets, and living beings, are made possible by increases elsewhere, preserving the overall cosmic trend. Understanding entropy invites us to reflect on impermanence, change, and the balance between order and chaos. It is a reminder that the universe is not static, but a dynamic flow moving inexorably forward. As you listen, imagine entropy as the cosmic rulebook, setting the pace for the universe's evolution and eventual fate. Next, we will explore the fascinating topic of cosmic background radiation, the ancient light that tells the story of the universe's birth. Chapter 17: Cosmic Background Radiation, the Universe's Ancient Echo. Long after the fiery birth of the Big Bang, the universe cooled and expanded, leaving behind a faint but persistent glow, the cosmic microwave background radiation. This ancient light is a whisper from the earliest moments of cosmic history, a snapshot of the universe just 380,000 years after its beginning. Katie Mack takes us on a journey through this relic radiation, explaining how it was first discovered in 1965 by Arno Penzias and Robert Wilson. Their accidental detection of this faint microwave glow confirmed the Big Bang Theory and opened a new window into the cosmos. This radiation fills the entire universe, bathing us in a nearly uniform glow with tiny fluctuations. These minute variations are the seeds from which galaxies and large-scale structures eventually grew. By studying the cosmic background radiation, scientists can understand the universe's age, composition, and evolution. Katie Mack emphasizes how this echo connects the universe's past with its future. It is a bridge linking the fiery birth to the possible cosmic ends we explore. The cosmic background radiation also reveals mysteries yet to be solved. Tiny anomalies challenge our models, hinting at new physics or previously unknown processes. As the universe expands and cools, this radiation will continue to fade, eventually becoming undetectable in the far future. Yet its legacy remains etched in the cosmos, a timeless record of creation. As you listen, imagine this ancient light enveloping the universe, a cosmic memory glowing softly through the vastness of space and time. Next, we will explore the role of neutrinos, the elusive cosmic messengers, and their impact on the universe's destiny. Chapter 18: Neutrinos, the elusive cosmic messengers. In the vastness of space, countless particles stream through the cosmos at nearly the speed of light. Among them are neutrinos, tiny, nearly massless particles that rarely interact with anything. Despite their ghostly nature, neutrinos carry vital information about the universe's past, present, and future. Katie Mack introduces neutrinos as silent cosmic messengers, born in the hearts of stars, during supernova explosions, and even in the earliest moments after the Big Bang. They pass through planets, stars, and galaxies almost unaffected, making them incredibly difficult to detect. Yet these elusive particles are key to understanding fundamental processes. Neutrinos influence the evolution of stars and galaxies, affect the balance of matter and antimatter, and may hold clues to physics beyond the standard model. Their nearly massless nature means neutrinos travel vast cosmic distances unimpeded, preserving information about the events that created them. Scientists use massive underground detectors to capture rare neutrino interactions, unveiling secrets about the universe's inner workings. Katie Mack also explores the role neutrinos might play in cosmic endings. Some theories suggest they could impact the fate of matter or contribute to phenomena like vacuum decay. As you listen, imagine the countless neutrinos passing silently through you every second, carrying whispers from across the cosmos. This chapter invites reflection on the unseen forces and particles shaping our universe's story, reminding us that much remains hidden yet crucial. Next, we will delve into the concept of quantum fluctuations, the tiny ripples that seeded all cosmic structure.
Chapter 19, Quantum Fluctuations, the tiny ripples that shaped the cosmos. In the earliest instance of the universe, before stars or galaxies existed, the cosmos was a seething, energetic sea of quantum fluctuations, tiny random variations in energy and density that occurred on scales smaller than atoms. These minute ripples laid the groundwork for everything that would come to be. Katie Mack guides us gently through the strange realm of quantum mechanics, where uncertainty reigns and particles pop in and out of existence. These fluctuations, seemingly insignificant, were stretched to cosmic scales during the era of cosmic inflation, seeding the formation of galaxies, clusters, and the vast cosmic web. Without these tiny variations, the universe would be a featureless expanse of uniform matter and energy. No stars, no planets, no life. Quantum fluctuations are the subtle architects of cosmic structure. These ripples also remind us of the deep connection between the very small and the very large, between the strange world of quantum physics and the vastness of cosmology. Katie Mack discusses how studying these fluctuations helps physicists understand the initial conditions of the universe and test models of inflation and other cosmic theories. As you listen, imagine these tiny ripples in the fabric of reality, invisible yet profound, shaping the destiny of all that exists. Next, we will conclude with a reflection on the cosmic finale and the enduring mysteries that invite our curiosity. Conclusion: Reflections on the cosmic finale. The journey through the cosmos, from its fiery birth to the many possible ends, reveals a universe both magnificent and mysterious. Katie Mack's guide has taken us through breathtaking theories, from the sudden silence of vacuum decay to the eternal cycles of the Big Bounce, from the unseen forces of dark matter to the whispering echoes of ancient radiation. Each scenario paints a different picture of the ultimate fate awaiting all that exists. Yet, amidst uncertainty, one truth remains clear: the universe is a place of wonder, complexity, and endless discovery. As we ponder these cosmic finales, we also reflect on our own place in the grand tapestry. The stars that once burned within us are now fading, but the curiosity and imagination that drive us continue to illuminate the unknown. The end of everything need not be feared, but embraced as part of the cosmic dance, a final note in a symphony that stretches beyond time. Thank you for joining this journey through the universe's possible destinies. May this exploration inspire awe, reflection, and a deeper connection to the cosmos that surrounds us.